Hi guys. Today we're continuing with the concept of solving a quadratic equation by factoring. But instead of starting with an equation and factoring to solve, we're going to be working backwards. So I'm going to be giving you the answers to the problem, and you're going to need to try to figure out what was the original question, what was the original equation. Before we get started, let's go over a couple of vocabulary words. Normally, when we're solving a problem, we say that we found the answer, but there are several other words that we can use besides answer when we're solving this particular type of problem. So when we are solving a quadratic equation, we can say that we found the answers, or a lot of times they're called solutions. If you remember from yesterday's video, we put the curly brackets and we called that a solution set. So it was the set of solutions. Another word that we can use is roots, and that's actually, I believe, the word that's going to be used today in the directions is roots. And then finally, we could also call these the x-intercepts. Now, that's a really big concept, the fact that we're solving for x-intercepts, and we explored it a little bit during our live session, but we're going to really actually dive deep into x-intercepts when we come back from winter break. But just kind of, have it in the back of your mind that what we're doing in this chapter is actually finding the x-intercepts of a graph. But let's go ahead and do a problem. So here's the original question. The question says, given the roots, and we just learned roots means answers. Given the roots 6 and -5, write a quadratic equation. So this is, again, telling us what our two answers are. Our two answers are 6 and -5, and then they want the original math problem that would give us those answers. Now, I hope that as you were working on yesterday's assignment, that you noticed a pattern happening as you were solving, that once you had factored into your two parentheses, that the actual answers to the problem had the opposite signs of what was in the parentheses. For instance, if you had a parentheses of x plus 2, when you set that equal to 0, you would subtract 2 on each side, and your actual answer would be -2. So in the parentheses, it was a +2, but the answer was a -2. That's a really important concept for today. For instance, on this example in particular, right, it's telling us that my answers are x equals 6 and x equals -5. And so if my answer was x equals 6, that means that my original question was x minus 6, because then I would have added 6 to the other side. And if x equals -5, that means that my original problem was x plus 5, because then I would have subtracted 5 to the other side. And so what we're going to do is we're going to take our answers, our solutions, our roots, and we're going to change the sign and throw them into some parentheses. Okay, so here I have my x minus 6 and my x plus 5. Those were the two parentheses that gave me the answers of 6 and -5. And then this was definitely not what the original problem looked like, right? This is what you got after you had factored it. So now we need to multiply this out until we get the original question. You can use the concept of FOIL or box method. If you're doing the box, these go along the outside and you're filling in the box because we've already factored. So we're not starting on the inside and going out. We're starting on the outside and we're filling in. And I can show you examples of that during class if you need to see that. Due to lack of space on the PowerPoint, I'm going to choose to do FOIL this time. I don't normally choose FOIL, but it does take up less space. So when I FOIL, it's first, which is x squared, outer, which is 5x, inner, which is -6x, and then last, which is -30. And then just to finish up the problem, I am going to combine like terms. And so the original question that I could have been given is x squared minus x minus 30 equals 0. And that question would have given us the roots of 6 and -5. And so the solution to this problem is this equation down here. Again, today we're working backwards, so your final answer will look like what yesterday's problems looked like. Let's do one more just to be certain. So here I'm giving you the roots are 0 and 1/2. And so again, I hope you noticed in yesterday's assignment that to get an answer of 0, you needed to have a GCF of the letter X, right? So to get X equals 0 without any other numbers, then you would have just had an X, right, like in front of your parentheses. Okay, so I mean, the other option you could do if you wanted to, you could do X minus 0 in a parentheses. You would totally get the same answer. Nothing wrong with that. So if you want to just always default to subtracting, that's fine. All right, so you can either do a GCF of X or you can do X minus 0. And then for your second parentheses, it's X minus 1/2. If you put X minus 0, you are going to do FOILing or the box method. If you just put the GCF of X, right, then you can just distribute it in and it looks like this. Now, in yesterday's assignment, all of the problems had whole numbers, right? We've never really factored, and we're not going to try to factor with fractions. So the fact that there's a fraction in this problem right now means that this probably was not the original question, and I should do a little math to make it look more natural to us. And so if I want to get rid of a fraction in an equation, something with an equal sign, I can just multiply each term by the denominator. So and it is, you have to multiply everything. So I'm going to multiply the x squared, I'm going to multiply the 1/2 x, and technically I'm also multiplying the 0. 0 times anything is still 0, but I have to put it in there. And then I get this, and now everything is whole numbers. If you want to check your answer, make sure that it does give you solutions of 0 and 1/2. You can always refactor this and solve it. So do what we learned yesterday to check your answer. One last thing before I set you free for today, I just wanted to have a friendly reminder that your exponent tells you how many answers you should have. So it's really good that we got an x squared in this problem because we did start with 2 answers. So you can always use that as a way to double check and just see if you're on the right track. This concludes today's lesson.